Hello, everyone, and thanks for attending this session. And my name is Yuqi from Arm. I'm also the Linaro LDCG working in LDCG BigData team. And in this session, I would like to talk about how to make big data fly on Arm64. I also would like to introduce a project named Apache Arrow to all of you, and share something and share what we have done on this project. Yeah, and okay. Nowadays there are some problems, and like reporting new products, forecasting, threat detection, machine learning, and the threat prevention. There are more demands for data are increasing dramatically. So then, modern data analytics is a huge challenge for all of us, and it's also a challenge to make data fly on Arm64. It's in big data world, there are some limits here. Every database and language has to implement its own internal data format, like speedup. It generates a lot of waste. You're moving data from one system to another system, involves costly, serialization and deserialization, and it's almost waste, 60% CPU waste on data copy and conversion. This conversion and duplication is unnecessary. In addition, more algorithm also must be often be rewritten for each data format between these systems. This is the very big problem for us. And you ask how to take this problem. Let's see. And first, we would like to put everything in memory. In memory, it's the because the low speed disk is the bottleneck of the I/O performance. So we can take up our advantage of the faster transaction and multi-use concurrency by leveraging in a memory database. It will accelerate our performance. And the other choice is GPU. GPU is the parallel computing architecture. GPU can accelerate our data science workflows and in our data analytics. And the third one is we can we can convert data to columnar data format. The benefits of the columnar data format are the cache pipeline and SMID. SMID means single instruction and multiple data. And the columnar data also can be used to GPU vectorized processing. And we also can leverage the distributed systems. We can take advantage of the scalability and in distributed system. Also, distributed system has faster calculation speed, and also it's the high fault tolerance. Okay? So I would like to introduce the Arrow. These 4 points mentioned above, are the solution to tackle these problems. But the Arrow is the in-memory columnar data format. Arrow also can be deployed as the distributed mode. Arrow also was integrated in some GPU memory architecture. So Arrow is the process and move data faster. Arrow is designed to make things faster. It focused on speeding communication between systems as well as processing with only one system. That's very efficient. Arrow specifies standard language, it's the independent, the columnar member format for flat data. Okay, Arrow also provides the inter-process communication. Arrow also supports zero copy streaming message and computational libraries. Arrow is organized. Arrow designed a columnar data format. So the columnar data formats I mentioned above it can take advantage of the hardware like the pipelining, SMID, cache locality, and to maximum CPU throughput. And Arrow's libraries implement the format and provide the building blocks, including high performance analytics. And many popular projects like Spark and Parquet, pandas use Arrow to ship columnar data efficiently or as the basis for analytic engines. The libraries are available for C and C++, C#, Go, Java, and JavaScript, and Rust. Arrow, the columnar is fast. Arrow can enable you to work with the data in Arrow columnar format in many languages that support many libraries. Okay, you can see the picture showing the slides. All systems utilize the same memory and format, and no overhead for cross-system communication. It means zero copy data process exchange, metadata and points to Arrow data arrays. Arrow libraries also enable third-party projects to work with Arrow data without having to implement the Arrow columnar format themselves. It will help these third-party libraries can be integrated in their projects. Okay, Arrow also simplifies the system architectures. It improves the performance and also reduce the ecosystem's fragmentation. It's easy to port a dataset into R language to system for machine learning in some use case without any overhead of the serialization, the deserialization. Okay, and like this table shows, the pandas has its own data format, and the PySpark also has. They all when they we can leverage the Arrow, they all use the same data representation. We call this format is Arrow batch. So you may ask, what is the Arrow batch? We can in this slide I will introduce the Arrow columnar format. Yes. Okay, and Arrow columnar format is also called as the common message pattern. It is consisted of the schema integration block, and the dictionary batch, and the record batch. This common message pattern, we send a series of message, the schema integration, and one or more record batches. And the schema integration is the logical description of the structure, and also is identification of the dictionary encoded the nodes. Dictionary batch is to contain some dictionary ID and its values, and the record batch is the ordered collection of the named Arrow data arrays. Okay, and another format is the read and access file. Read and access file is consists of the record batch and the schema file layout. Schema file layout is the table schema, and it contains table schema and block location at the end of random access file. It enables users to select any record batch or any color in the dataset very cheaply and very quick. It's efficiently. Okay, this is the example of the columnar data. This data is one person. Okay, it's some persons. It's name Jack, the roles, and their age, their phones. In Arrow columnar format, they Arrow put name together and put age data together and put phones together as a different column. Just showing the slides, and in name column, the offset 0 is point to Jack, and by offset 4, and it's the point to Rose, and the age is here, the phones is here, and they are very, they are organized in columnar format. Okay, go back to Arrow columnar data. This is to show the details in the record batch. Okay, in record batch, it is consist of the the data header and the name data followed by this header and the age and the phone. Okay, each box is the contiguous memory, and we can utilize the cache locality. It's pretty efficiently for in the memory. It's the contiguous columnar layout. Will leverage the SMID modern processors. The cache locality, and it also can minimal the structure overhead, and it can support the constant value access, or it also can operate directly on a columnar compressed data. Okay, it's the next in this part, and I would like to what we have done for Apache Arrow. And first, we leverage the CRC parallel algorithm to optimize the hash computation with CRC extraction and ARM crypto extension. You can see this table, this chart, and the hash function was only just implemented by software. It gets the 0.9 kilobytes per second throughput. And if we leverage the ARM CRC 32 instructions and crypto extension, we can get 8.8 kilobytes per second. We get the 9-fold speed up. The performance boost is we get the performance boost on AX64. The next, we also leverage the ARM Neon instructions to implement the function of the validating the ASIC string function for Arrow. And as you see in this slides, and in a large ASIC string data size case, in this case, we got the you see the 29 gigabytes per second throughput, compared to just to software implementation. We got about a 25-fold speed up. And we also add support to ARM, CPU info detection for ARM. We also implement Arrow memory benchmark for Arm64. We also fixed CPU info compiling issues, and we also implemented the Arrow non-ACID string validation function, and also fixed some memory bench issues here. And Yibo Cai, he is a Linaro member engineer from Arm in our team, also made huge contributions to Arrow community. If you are interested in what we have done in detail, you can see the Jira tickets listed in this slide. And Yibo Cai and me are the members of the contributors of the Apache Arrow 1.00 released. This is official released. Okay, in this part, I will show to demo all of you to show the huge performance boost on Arm64. The first one is we speeding up the PySpark with Apache Arrow on Arm64. In the function Spark SQL, it will enable the arrow by this command, and it will convert the data frame in Spark to data frame in pandas. We can get about 40-fold speed up. Okay, let me show you the details. And first, everything is in R. This is the R. Sorry. This is the R. Okay, and we run the PySpark here. Now, first we import some facilities here. See. And the second, we can create our data sets. This is simple data sets. Okay, let me show you the schema, the data schema here. It's the ID is the long data type. It's the X is the double. Okay. Okay. Let me show you the how long this data schema. How long will we take to convert this data to a panda data frame? In this way. Sorry. Just wait a minute. It will take about 1 minute. Yes. Okay. Section. It takes a long time to convert this data to pandas data frame. Okay, it takes totally 46 seconds. So now let's enable the arrow in the Spark. Okay, let's see. Sorry. Okay. Let's see again. When we enable the arrow in Spark, how long will we take to convert this data? Okay, it's just take only 1 second. Okay, we get the huge performance here by enable the Spark by enable the arrow in Spark. it's about just to remain the 40-fold speed up here. Okay, the next demo is streaming Arrow performance on Arm64. In this demo, we will first generate an example data set. We will create a 1 GB size totally, and then we will construct and write this data to the memory, and then read them and data back and to see how fast Arrow streaming performance. Okay. Okay. Let's see this this demo script first. Okay. Okay. In this demo, I will create a 1 GB data size, and I will also, divide this data into the different blocks. Means chunk size. It's ranged to 16 kilobytes to 16 megabytes, and see the performance difference. Let's see it. Okay, this is the the 16 kilobytes chunk. We take this time. We take about 6 seconds. When the chunk size is the 16 megabytes, we just take only 0.06 seconds to to handle this conversion. Okay, let's see it. Okay, and as the streaming, the chunk size grows smaller, the cost of the reconstructor contiguous the claimer pandas data frame increase. Okay, because of the cache inefficient memory access patterns. So we can see that if the block is 16 megabytes, we can get the throughput about the 22 gigabytes per second to reconstruct a 1 gigabyte data frame. It's really efficient. Okay. Okay. The last, I would like to thanks Yibo from Arm, and also thanks to Linaro LDCG BigData team, Ganesh and Junhe. And it's all for my sharing today. And if you have any question, please feel free to contact us by email, post here. Okay. Thank you very much. That's all from my side.